Welcome to our today's lesson. Today we focus on correlation analysis. We begin by trying to understand what is correlation. And correlation analysis first helps us to establish whether variables that we are dealing with are associated or related, either they have any connection. Now, when you look at just two variables, x and y, we say they are correlated if a change in one variable, whether negative or positive, causes a change in the other variable. So if x is changing and is causing y to change, then x and y are correlated. The correlation between x and y can either take a positive direction or take a negative direction. At what point does it take positive? So you say x and y have a positive correlation if an increase in one variable cause an increase in the other variable, meaning that the movement of the variables is in one direction, as shown in the diagram. The movement, both of them are increasing, or both of them are decreasing. Negative correlation, x and y will have a negative correlation if one variable is increasing and is causing the other one to decrease, meaning that they are moving in opposite direction. That is shown in the diagram. One is coming down, the other one is going up. So in this diagram, you can see that x, one way x is increasing, rather y is coming down. Y is coming down. Now, x and y can also fail to have a correlation. So how do you demonstrate that x and y have no correlation? Now, if x and y are not correlated, what will happen is that when one variable changes, it causes no change on the other variable, that it does no effect on the other variable. Now, in this slide here, we are saying that when you look at this diagram here, that that diagram tries to explain that a change in y is causing no change in x, meaning that they are not correlated. I take an example here. There I have y1, and here I have y2, meaning that y has changed, but x remains exactly in one point. While the other one tries to explain the diagram, that in this case, x is here, 1, and here x has changed to x2, while y remains at the same point, meaning that the two variables, x and y, are not correlated, since the change in x is causing no change in y. Now, how do we measure correlation? Correlation is measured by a factor, it's measured by a method we call quantity we call coefficient of correlation, which we denote like this. Now, that quantity, that coefficient of correlation ranges from -1 all the way to 1. So it will move from 1, less or equal the Rxy, less or equal to 1. That is the range. Now, when it is from 0 to 1, not 0, but it is all the way to 1, then we say the two variables have a positive correlation. They are moving in the same direction. Change in one, an increase in one will cause an increase in the other, and a decrease will cause a decrease. And when it is -1 all the way to something close to 0, then we say they are negative. That is, one is increasing, the other one is coming down. When it is 0, when the correlation coefficient is 0, it means they are not correlated, meaning that a change in one variable, if x is changing and y is not changing, the diagram will look like that. That is y and x changing, y not changing. But if y is changing and x is not changing, the diagram looks like that, as earlier indicated. There is no correlation. Now, how do you interpret correlation coefficient? If the correlation coefficient is exactly 1, it means that X and Y have a perfect positive correlation, meaning an increase in X causes equal increase in Y and vice versa. And when X is -1, it means they are perfectly negatively correlated, meaning an increase will cause equal decrease in Y. They are going in opposite direction. When R of X, that is the coefficient of X and Y, the coefficient of correlation between X and Y is closer to 0, we talk about weak correlation, because when it reaches 0, there is no correlation. Otherwise, when it is approaching 1, when the R of X, the coefficient is approaching 1, we talk about positive, strong positive correlation. When it's approaching -1, we talk about strong negative correlation. Let's demonstrate one or two things here. Now, suppose X and Y have a positive correlation. Suppose when X was equals to 30, Y was 80. Then somebody tells you to find the value of Y when X has changed to 40. Since the two variables have a perfect positive correlation, it means the change in X will be exactly equal to the change in Y. So the change in X here, X has increased by 10. So Y will also increase by 10. So I had 10 here to get, I had 10 there to get 90 here, because both of them have equal, they are causing equal change. Now, if the two variables are perfectly negatively correlated, if X was 30 and Y at that point was also 80. Now, if X changed to 40, now in this case, the change of X, because it is increasing, is 10. So Y, the change in Y will be 10, but in this case, it will be negative. It will be moving on the opposite direction. So what we shall do, to get the new Y, you get the 80, then subtract the 10 to get 70. So in this case, X has increased by 10 to 40, and Y has decreased by 10 to 70. Thank you very much. See you in our next class.